All right, let's go ahead and do all of number 16 real quick. To find a vertical asymptote, you need to look in the denominator of your thingy. We call those fractions. So look in the denominator of your fraction. When is the denominator of your fraction equal to 0? That will tell you where you have an x-intercept. So if we have 2x minus 3, if we set that equal to 0, then we would get 2x equals 3, and x equals 3 halves. So that will be the equation of my vertical asymptote, x equals 3 halves. And to figure out your horizontal asymptote, you need to look at the leading coefficient and the largest term, the term with the largest degree. So we need to look at 8x over 2x. And how does 8x over 2x simplify? Well, the x's cancel each other out, and you're left with 8 over 2, which is 4. So our horizontal asymptote is at y equals 4. So let's do the same thing for b. So I guess we need to scoot over here. So for b, 5 over x minus 3, well, that tells me that I have a vertical asymptote at x equals positive 3 and a horizontal asymptote at y equals 0, because the degree of the denominator is larger than the degree of the numerator, which tells me that my horizontal asymptote will be at y equals 0, always, always, always. So let's do C now. Right off the bat, I notice I have a power of 1 on the top and a power of 2 in the bottom, so I already know that y equals 0 will represent my horizontal asymptote. So let's figure out where my vertical asymptote will be, or asymptotes. We need to factor it to figure that out. So pull out that 2, and what are you left with? You're left with x squared minus 1, which is a difference of squares, which factors as x minus 1, x plus 1. So this thing will have two vertical asymptotes, one at x equals 1 and another at x equals negative 1 for my VAs and 0 for my HA. Let's do D now. D, let's find the vertical asymptote. So look at the bottom. What x value makes 3x minus 2 equal to 0? Well, that's the same as saying what x value makes 3x equals 2. Solve for x. I didn't make a coherent sentence there, but divide by 3 on both sides, so x equals 2 thirds is going to be my vertical asymptote. Horizontal asymptote is going to be y equals 0, because the denominator has a larger degree, so you don't have to do any work for that. So E. In the numerator, I have a degree of 1. In the denominator, I have a degree of 1. So that tells me, since the degrees are the same, all I need to do is look at my coefficients, which is 9 over 4. So y equals 9 fourths will be my horizontal asymptote. For my vertical asymptote, look at the factor in the bottom. 4x minus 8 factors as 4 times x minus 2, which means x equals 2 will be my vertical asymptote. Let's do F now. A problem like this should be really, really snappy. Horizontal asymptote, look, x cubed over x cubed. So I'll be left with 8 over 2 is 4. So y equals 4 is my horizontal asymptote for part F. Vertical asymptote, look at this thing. This is not going to be fun to find the vertical asymptote for, because we need to know when is 2x cubed minus 3 equal to 0, which means we need to know when is 2x cubed equal to 3, which means we need to know when is x cubed equal to 3 over 2, which means we need to know when is x equal to the cube root of 3 over 2. And that's gross, but that's where my vertical asymptote will be, the cube root of 3 over 2. So let's go ahead and do G real quick. I have x cubed over x cubed, which means my coefficients will tell me where my horizontal asymptote is. So y equals negative 1/2 is my horizontal asymptote. Vertical asymptote, factor the bottom. 2 times x cubed minus 1. What am I doing? Minus 4, if I can do math. X cubed minus 4. So we will have a vertical asymptote when x cubed minus 4 equals 0, which means x cubed equals 4, which means we have a vertical asymptote at x equals the cube root of 4. Just set the bottom equal to 0 and solve it, and you'll get your vertical asymptotes, even if they're not pretty. F of x equals x plus 5 over x minus 1. Well, notice we have x over x as our largest degree terms. So we get x over x is y equals 1 for our horizontal asymptote. We have an x minus 3 in the bottom, which means x equals 3 is our vertical asymptote. And finally, the last one, 8 over 2x cubed minus 3. So it will have a vertical asymptote when the denominator is equal to 0. So let's factor it. 2 times x squared minus 3 halves is what you would get if you pulled that 2 out. X squared minus 3 halves is a difference of squares, right? So if you set x squared minus 3 halves equal to 0, you will get x squared equals 3 halves, which means the two vertical asymptotes will be at x equals plus or minus the square root of 3 over 2. So not nice numbers, but still giving us vertical asymptotes. Horizontal asymptote, the degree is larger in the bottom, so that means y equals 0 for the horizontal asymptotes.